Yeah, Mitch here, and I'm still in the mood for another Metasound tutorial. And recently I needed a surround panel in Metasounds, and since Unreal Engine 5.3, there is the option of switching the channel configuration of a Metasound not only from mono to stereo, but also to 5.1 surround, 7.1 surround, but currently there are no tools or nodes whatsoever for that, and also no surround panel, so I had to build one myself, and I thought, why not share the process? And I will also leave a download link for the surround panel Metasound patch in the description, so you can download it, use it right away, save a little time. So let's have a look. So this is an empty Metasound, and the first thing we need to do is let's go to the Metasound tab here and switch the output format from mono to 5.1 in our example. This will give us the outputs for 5.1, front left, front right, front center, the LFE channel, and then left and right for the rears. And well, the surround panel is a Metasound patch, so I can just drag it in here, and this is what it looks like. And first thing, if we want to use it, we just have to hook it up. So quickly, let's connect the channels, front right and the center. And then I've got the LFE and the rears. And on the input side, we've got, of course, the audio input here. And then we've got left and right panning. This one goes from -1 to +1. And 0 is center. And the same is true for front and rear. -1 will be front, +1 will be rear. And LFE, this is a volume knob, so if you connect an input, then set the knob to volume knob. And then some booleans as well. Let's start with the last one. A noise generator, you can switch from the audio input to a noise burst signal just to check things, levels and stuff. And it will be quite convenient for us to showcase the levels and how they're panned. And there are another two options. One is to omit the front center. In 5.1 routing, between the left and the right speaker is the center speaker, and the signal will be panned from left over the center to the right speaker. But if you want to use a phantom center, so without the center channel, just like in conventional stereo setups for the front, then you can set this boolean to true, and then there will be no center channel, and the signal will be panned from front left to front right with a phantom center here. And another option, you can pan the incoming signal directly to the center speaker. All other speakers will be switched off, and the signal goes directly to the center speaker. And yeah, these are the options. So let me quickly hook this up with some inputs. So like in a good cooking show, everything is ready within seconds, and we can take the pie out of the oven and everything is hooked up. Let me quickly go through the inputs here. The two panner knobs, left and right and front to rear, are both linear knobs with value ranges from -1 to +1. And the LFE level is, as I said, a volume knob with ranges in dB from -160 to 0. And for the audio input, I'm just using a wave player in mono. And for these Boolean values here, I have this little setup, which is just a little workaround, so I can trigger different Boolean values while the Metasound is playing. Because if I'm not connecting with anything, I can set the value here before I start the Metasound, but once the Metasound is playing, I can change it, but it won't do anything. So this is my little setup here that allows me to trigger my Boolean values. So I'm setting the trigger, and the trigger sequence is basically a trigger toggle. And the value function here is just sending out different values depending on which inputs are triggered. If the set input is triggered, it's going to send out the target value, in our case true. And if it's reset here, it's going to send out the initial value, which is false. This lets me toggle the Boolean values here while the Metasound is playing. So before we check this whole thing out, let's quickly consider what to expect, because the interesting thing with a surround panner is the level distribution and the panning laws. And if we remember, with a traditional stereo speaker setup, there is no center speaker. So if you want to pan a signal exactly in the center, you're going to send the signal to both of the speakers exactly level matched and phase aligned. And when you're doing this, this will create the illusion of a phantom center, of a sound source exactly in the center that isn't actually there. But what happens if you do that is that we perceive the level of the phantom center louder in comparison when it's panned only to one of the speakers. So we have got two actual sound sources, left and right, phase aligned and level matched, and both of these sound sources are reaching our ears, and this will add up and give us the perception of up to 6 dB more level. And in real life, it's not going to be 6 dB because it's not always perfectly phase aligned and the acoustics of the room and stuff like that. So normally in analog consoles, there is a compensation for that effect, which is the panning law. And in most of the analog consoles, they are using a -3 dB panning law, which just says that towards panning the center, the signal gets 3 dB lower. And whatever, this is something that still is being used also in the digital domain, in DAWs, and also here in the Unreal Engine. So if you're using the panner here, we also got that panning law, and you can choose between linear and equal power. So equal power is just another panning law, another solution to that whole thing, which is cool that they're using the equal power law here, because this is something that normally is used when it comes to surround panners. So panning between front and rear speakers is normally done with a panning law of equal power. And so that's good for us when we're trying to build a surround panner. And this is how it's going to look like in a surround setup. So if we're panning from front to back, we are using the panner with equal power distribution. Same is true for panning from left to right on the rear. And it's a little bit more interesting at the front, because we've got this additional center speaker here. So we have to treat the front like two stereo setups with a shared speaker, which is the center speaker. So we've got one equal power distribution from left to center and another equal power distribution from center to right. And if we choose the option of omitting the center speaker, this needs to switch to one standard panner from left to right with a phantom center with equal power distribution. So let's go check this out. Okay, let's start all the way to the left and all the way to the front without any LFE level. And of course, on a YouTube video, you're not going to hear it in surround, but let's just watch the meters, which in our case now is much more interesting. So if I'm panning from left to right in the front, it's going to use the center channel. If I'm exactly at the center, it will be only the signal on the center channel, no signal on the left and the right. And if I'm continuing to pan this to the right, it will crossfade to the right speaker. And if I'm exactly halfway between right speaker and center, which is 0.5, I'm trying to be as precise as possible. Unfortunately, I can dial it in. That's not possible with decimal points. Anyway, almost correct. And you see, in this case, we have the more or less exact same level between center speaker and right, which gives us a phantom source or a phantom center between right speaker and center speaker, which is halfway between those two. So that is cool. It's working correctly. So let's pan this in the center and move the signal back to the rear speakers. You see rear speakers coming up, center speaker slowly fading away until there's only a signal in the rear speakers. And as we're in the center, we're using the phantom center here, which means those two signals are exactly same level, phase aligned, and they will provide a phantom center at the rear. And if I'm moving the signal back to the front speakers halfway, let's be precise here, you see that in the front, the center is only the center channel. And also interesting to see, because we're using two signals with a phantom center here, the level is a little bit lower according to the pan law than this one signal that is only coming out of one speaker. But it's a good moment to test out our no center toggle here. So this will eliminate the center channel and will do exactly the same in the front as we're doing here with the back channels, with the rear channels, just using a phantom center. So we're triggering that. And you see that now we've got exactly the same levels for left and right in the front and the back here. So that's working too. And as we're exactly in the middle between front and rear here, exactly the same things are going to happen for the left and right front and rear channels. Another option that we can use is directly panning to the center channel only, which just switches off all other channels and will route the signal exactly to our center channel. Sometimes this is useful for a dialogue or some signals that you want only on the center channel. And then we can also switch to our noise generator. Yeah. We'll just mute the input signal and switch to the noise generator. We can do exactly the same thing here. Where is it? Now. And let's use the center channel again. Yeah. So that's basically how this MetaSound patch as a surround panner works. And now let's open it up and see how it's built. So this is the MetaSound patch. It's not too big, not too complex. And let's start here. We've got an input selector, which just basically switches between the audio input and the noise generator. And the noise generator is just the simple noise module being modulated by an LFO set to square shape. And from the input selector, it goes to the panners. And let's start with the panning from front to rear, which is just a standard panner set to equal power panning law. And we've got this input here, as I said, from -1 to +1. And in this case, output left would be front and output right would be the rear channels. So let's continue with the easier setup, which is for the rear channels. So this one goes into another panner here, and this panner gets its information from this input, from the left-right panning input. And the left channel goes out to out rear left, and the right channel goes out to out rear right. The only thing that's in between is this option of sending an input signal directly only to the center speaker. And if this happens, then of course we need a crossfade here, which just sends the signal to silence if the option is selected, and if not, then we're just passing on the signals to the output. So that's pretty easy. Next in the signal flow is panning the signals in the front. So we're taking the signal of the first panner, of the front rear panner, from the left output and feeding it up to this section here. And well, we've got the center speaker here, so we need to implement something that separates the left and the right channels from the center. So we've got the input knob from -1 to +1 for left-right panning, but we need to use the same input knob for the rear signals and also for the front signals. So that's the challenge here, using the same input knob for two different situations, but as you will see, that's not so hard. So remember, we've got in the front, we've got these where's my mouse? Here. We've got these two panners here, one from left to center and one from center to right, and we want to control that with one knob that goes from -1 over 0 to 1. So we just need to map the values here. And the way I'm doing this is using two panners here, 1 and 2. You see they are in series here, and the way to do it is This is the panner for left and center signal, panning the signal from left to center. And our input goes from -1 to +1. And so what we need to do is first insert a clamp node here, which just clamps the input to the first half of the knob, basically. So from -1 to 0, and everything that goes above 0 will be clamped here. So we've got values coming out of this node here, of this outlet here, only from -1 to 0. And we need to map them back to -1 to +1 for the stereo panner here. So we set the input range from -1 to 0, just as we clamped it here, and then we map it back again to the full range of what we need here for the panner, from -1 to +1. So this is the first panner from left to center, and we can use the left signal of this panner directly for the front left output. The right signal will be part of the center signal, but we need to use a second panner here because the center signal is the shared speaker between those two panners here. And for the second panner, we're doing exactly the same, but we're clamping the signal for the second half of the knob. So we're clamping it from 0 to 1, just using this section here. And we will remap the values from 0 to 1, which comes in from here, back again to the full range of -1 to +1. And we're doing the panning here. And so we're using the left output here as the center channel and the right output as the right channel. And that would be basically it, but we've got these two options here. One option is not to use the center channel for the front panning, so using a phantom center for the front channels. So basically what we need to do is use some crossfaders here. The crossfader in the middle is for the center signal, which just crossfades it to silence because we don't want to use a center channel here. And the other two crossfaders are for left and right signal, and in order to have a correct panning, we need to use a standard panner here, which is also fed from here, from the front left panner. And we're just doing a normal panning, just as we did for the rear channels. And then we're feeding the outputs of this standard panner here to those crossfade nodes. So we're just basically crossfading between the logic that we implemented here to a simpler logic with a default panner. And the second option is the possibility to route our signal directly to the center and switch off all other channels, which just happens here. So for all channels except the center channel, the crossfades will look like this one. Option 0 is whatever we came up in the signal flow up to this point, and option 1 would be silence. And this is true for all of the signals. So I'm using that for left, right, and also for, where are they? For the rears, we've got the same crossfades here. And for the center speaker, we're crossfading between the standard center signal and one that is directly taken from the input selector. So that's that option. And then, of course, we've got the LFE level, but this is just basically a multiplier by float, and we're using a volume knob here and just dialing in the level of the LFE, which has basically nothing to do with the surround panning. It's just an additional channel that you can dial in. And of course, we need to switch the LFE channel off if we are using the direct to center speaker option here, which happens here, same crossfade. And that's basically it. So that's really not a very complex setup here, but it works nicely, and I hope some of you find it useful and can use it in your own projects. So that's it for today, and as I said, you can download this. I will put a download link in the description text, and it will be just a simple U asset, so you can just throw this into your contents folder and you should be ready to go. It's just a Metasound patch without any dependencies, so that should work. And yeah, thanks for listening, and see you next time. Bye bye.